So in this problem, we are given that the P, Q, R, these three numbers are in arithmetic progression, and we need to show that the Pth, Qth, and Rth terms of a GP are also in GP. In other words, we have a geometric progression where we need to show that the Pth and the Qth and the Rth terms, these three terms are GP, with a condition that three numbers P, Q, R are in arithmetic progression. So let's begin. First, we will need to specify the first term and the common difference. So let the first term be, we're going to represent by the first term by the letter A in uppercase, and the common ratio will be the letter R in uppercase as well. Then the Pth term, we need to show that the Pth, Qth term are in GP. So let's find out the Pth term first. So the Pth term of the geometric progression will be given by the first term multiplied to the common ratio, which is R, and R will be raised to the power of P minus 1. So let this be equation number 1. Then the Qth term will be given by A times R raised to the power of Q minus 1. So this is equation number 2. Then we have the Rth term, AR. So this will be given by A times R raised to the power of R minus 1. So this is equation number 3. Now we need to show that the Pth, Qth term and Rth term are in GP. If the Pth, Qth and Rth terms are in GP, then it must follow that the Qth term divided by the Pth term must be equals to the Rth term divided by the Qth term, or the square of the Qth term must be equals to product of the Pth term and the Rth term. Let's start from the right hand side. On the right hand side, we have the Pth term multiplied to the Rth term. So we'll use equation number 1 and equation number 3. So that means we have the Pth term, which is A times R raised to the power of P minus 1, multiplied to the Rth term. So that will be A times R raised to the power of R minus 1, which is going to give us A squared multiplied to R raised to the power of P minus 1 plus R minus 1. Fine. So that means we have A squared equals to R raised to the power of P plus R minus 2. Now it's given here that these three numbers P, Q and R, these three numbers are in arithmetic progression. If they are in arithmetic progression, then Q minus P, that must be equals to R minus Q. Or in other words, 2Q must be equals to P plus R. So that means in place of P plus R, we can replace that with 2Q, such that we have A squared multiplied to R raised to the power of, we have 2Q minus 2. So we can now rewrite this as A squared multiplied to R raised to the power of 2 times Q minus 1. So we can raise everything to the power of 2. So we have A times R raised to the power of Q minus 1 whole squared. And this is nothing but a Qth term. So this is the Qth term whole square, which is the expression on the left hand side. So we have successfully showed that the Pth term, Qth term and the Rth term, they are in geometric progression provided P, Q, R are in A